Today we are going to learn chemistry, Hund's rule for maximum multiplicity. So the statement of Hund's rule basically says that when several orbitals of equal energy, which are also known as degenerate orbitals, are available, the electrons first fill in all the orbitals singly before pairing in any of these orbitals. So let us say that this is a representation of shells in p orbitals. For example, let us take p orbitals. So we know that p orbitals have the capacity to have six what four so basically p orbital has p subshell has three orbitals, which I just circled, and each orbital has the capacity to occupy 2 electrons. Okay, so basically let us say that we have to fill 4 electrons in this p subshell. So how will I fill them? According to Hund's rule, each electron has to fill in singly before they start pairing. So it's like you can't fill it like this. Okay, this is an electron, we represent an electron like this is, let's say, the positive spin. So this is the opposite spin of the same electron, of another electron. So according to the Hund's rule, uh, this p thingy is has same energy level, it is constant in its energy. So when several orbitals of equal energy are available, the electrons first fill singly, meaning 1 2 3 4. It won't go like 1 2 3 4. This is wrong. The right way is fill them singly first and then go on doubling. Excuse me. So completely filled or half filled orbitals give extra stability, but there are exceptions to this rule. Okay, so we have the anomalous behavior of two elements. Anomalous behavior of copper and Cr for chromium. Okay, so let us first study chromium. Yeah, chromium. So basically the order in which we fill electrons is 1s2 2s 2p6 3s2 3p6 separated by commas, obviously. 4s2 3d4. Alright, so this is how we fill electrons, and this is how it should be. Okay, so the 3D thingy has 4 electrons. Okay, so let us draw the 3D shell here. So it has 1 2 3 4, 1 2 3 and 4. Okay, so this is the 3D shell, and it is kind of half filled, so it has less stability. So the inter-electronic repulsion forces one 4s electron to enter the empty 3D electron. Okay, so it's like this. So this is 3D, 1 2 3 4. So 1 2 3 4 and 4s. This is 3D, this is 3D, this is 4s, which is 2 electrons. So 4s is just this. So basically this makes the 3D shell very unstable, because as it is not paired, and on top of it it has an empty orbital, this one. So what happens is this one electron goes to 3D to make it more stable. So what happens is hmm, not this big, we need 5, right? 1 2 3 3, okay, 1 2 3 4, okay. So 1 2 3 4 5 in 3D, and 4s is just this. So this way everything is pretty much balanced. This is not entirely unstable, and this is not entirely stable as well, because we fill them singly first so that they are more stable. So this way all 3D and 4s are remain singly filled, instead of both of them, I mean one of them being completely filled and the other being very very unstable. So this is for chromium. Let us see one for copper as well. So copper has the atomic number 29. So the expected configuration is 1s2, 2s2, 2p6, 3s2, 4. Okay, no, that's not how it is. Alright, so it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 9. Okay, so that makes 29. So the 3d orbital, let us say the 3d orbital has 9. So 1 2 3 4, 1 2 3 4 5. Okay, this is very untidy. 1 2 3 4 5 6 7 8 9, right? So this is incomplete. Okay, is neither half filled or completely filled. Okay, 3D is neither half filled nor completely filled, hence it has less stability. The intermolecular repulsion forces from 1,4s electron, which is obviously completely filled, forces this thing to enter one half filled 3D electron. Okay, so that it attains stability. So drawing it all again, this thing goes in here, so this becomes completely filled, and this is still singly filled, meaning it can still do with one electron, but this thing was quite dangerous. Okay, this thing, okay, wait, okay, so this thing is quite dangerous because it is neither half filled. By half filled I mean it is not in this particular state where every subshell has one electron, which is not the case, because here the first 4 of them are, okay, let's use a different color. Okay, so the first 4 of them are completely filled while the last one is a single, right? So this is more dangerous than this is, because here everyone has an electron, and they are in the same state or in the same phase, unlike this, like this. So basically that is half filled and completely filled. So when one electron goes here, it makes more sense, because this is still very stable and this becomes more stable than it is. So the configuration is, the final configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Okay, so this is all for today. Thanks for watching. Do like our channel.